Section 7.2 is about the ambiguous case of the law of signs. Ambiguous means unsure how it works, so it's like unclear, kind of vague. So the ambiguous case happens when you're given case 2 from our notes, which is side-side angle. Notice I did not write that the other way. It is side-side angle. No cussing in this class. But the problem with the ambiguous case is that there is a potential for you to have literally no triangle that works, one triangle that works, or two triangles that work based on the information that you're given. So we actually have to do a little bit more work when we are given this ambiguous case to figure out, first of all, how many triangles there actually are that fit this description, and then what they are. So here are your table of outcomes. If angle A is acute, and I'm going to go ahead and put like a little bar right here. Notice there are 4 options for when A is acute. When you're given, the only angle you're given is an acute angle. There will be 0 triangles possible if, when you solve using the law of signs, that the sine of big B is greater than 1. If that happens, we know sine can never be bigger than 1, so we actually, it's broken. The triangle won't close. It would look something like this little bitty leg right here would just be swinging off and not actually closing the triangle, so we don't have a triangle that works in this scenario. Some other things to know, that the A value has to be less than the height, which is less than the B value you were given. So the 2 sides are in that particular order compared to the altitude or the height of that triangle. You will have exactly 1 triangle if A is acute and the sine of B is exactly equal to 1. If the sine of B is exactly equal to 1, then B is a right angle. So we know that the A side length is your height, and your height is less than that side B. So if the sine of B becomes 1 exactly, you're working with a right triangle. There's only 1 triangle that will work. You will also only have 1 possible triangle if 0 is less than sine of B, which is less than 1. However, H would actually be less than A, which is less than B. So your height of your triangle would be less than that long side that we are the second side, which is less than the first side. And wow, I just wrote down the whole wrong thing. I hope you're not writing in pen. I'm so sorry. That's for the next one. This should say A is greater than or equal to B. Now that matches the picture. Duh. So your side the second side is longer than the first side. So angle side, that second side length is longer than the first side length. But, and this is the important one, if A is acute, there are 2 triangles that can be formed when 0 is less than the sine of B, which is less than 1, so between 0 and 1. And in this case, the height is less than the A, which is less than the B. In this case, and what's important here is that you need to remember that angle A plus your second option angle has to remain less than or equal to 180 degrees. Now that means nothing to you yet, but when we see a problem, I'll come back to that statement that I wrote in red that's really important. Here's what happens with this triangle where there's 2 options. Let's say that you have this angle A, you have side length B, and then you have a number for A. But that A length could either touch the triangle here, or it's specifically the right size where you could swing it back this direction and it would still touch that line. So we have 2 triangles that can be created in this scenario, and we'll have to solve for both. So that's going to be your we'll put a little exclamation point next to this guy. This is going to be the one where you'll answer with 2 triangles. So you'll have to do double the amount of work. When the A value, the angle you are given, is obtuse, there's only 2 options. There will be no triangles. Again, if the sine of B is greater than or equal to 1. Greater than 1 doesn't make sense because sine is never bigger than 1. And if it's exactly equal to 1, that's a right angle, and we can't have it actually close. It would end up being some sort of quadrilateral to close. It would never close as a triangle. Our obtuse, we also have an option for there to be exactly 1 triangle, and this occurs when 0 is less than sine of B, which is less than 1, given that A is larger than B. The next 2 little boxes you have here on this page and the next page are helpful hints for the steps to do. Their wording may not make sense right now, so I'm not going to read through them. We are just going to highlight this part right here. This is important. We'll remember this. But really what's going to help is seeing an example of this in real life happening before any of these words that are in these boxes make sense. So I'm not going to read them at you yet while they don't make sense. The next box, though, we're going to fill some stuff in. If we're finding solutions of side-side angle triangles, again, this is case 2, we need to first make sure we understand the number of triangles that are satisfying this case. So we're going to have the side-side angle, A, B, and A, be given in this triangle. We can use the law of sines with A over A and B over B to find the sine of B. If the sine of B is greater than 0 no matter what, there are 0 triangles that satisfy the given conditions because sine will never be bigger than 0. If sine of B is equal to 1, then one triangle satisfies the conditions and that angle is 90 degrees. Those two make sense. Then when we get weird is when sine of B is between 0 and 1. Then there is either 1 or 2 triangles that exist and we have to figure out what to do. If sine of B is equal to some value k, then we use inverse sine on our calculators of that value k to find B1. So that's the first angle, our first option for the angle. Then we have to decide what the second option would be. To find the second option, we would do 180 minus that first option for B because they're supplementary and they would have the same value for inverse sine. If that value, A plus B2, is less than 180, this is important right here. If you add A and you add that new second angle you found, if it's less than 180, then a second triangle actually does exist and you'll have to solve for it. In this case, you will use B2 as the second triangle. Again, these words don't really make sense till you see it in action, which is the examples you'll see in the notes today. Example 0 is important to look at before we really start solving. It's your obtuse option, and I've already actually filled it all out because it's a ton of writing and I figured you didn't want to do that. But it says, without using the law of sines, explain why angle A being 104, A being 26.8, and B being 31.3 cannot be valid for a triangle. Since A is greater than 100, that should not say not greater than 180. That should say 90. Beep, beep, beep. LOL. Since A is greater than 90, it's an obtuse angle. Angle A has to be the largest angle. Since it's bigger, it's obtuse, and thus side A has to be the longest because the biggest angle is across from the longest side. However, B is bigger than A. This breaks this because we know A has to be bigger than B, so it's impossible for this triangle if A is obtuse. So basically, what I wanted you to remember here is that largest angle is across from the longest side. And vice versa. Medium goes to medium, small goes to small. So if you get an example like this, where your obviously largest angle is across from a medium side length or a small side length, that's wrong. The largest angle has to be across from the largest side. So what that does is it gives us a way to check our work. If we get an answer and it's a really large angle, but the side length is really small, something happened and that's wrong. Largest angle, longest side. Smallest angle, smallest side. Okay, let's solve some ambiguous triangles here. We're going to solve the triangle if B equals to 55 degrees 40 minutes. That's big B. Little b is 8.94 and little a is 25.1. I find it helpful to always draw a picture because for me, that helps me figure out what I know about this image. So we'll have angle B here, which is 55 degrees 40 minutes. Little b is across from it. That means this is 8.94 meters. And because I know this is going to be side angle, that means I know that this other side is right here, 25.1 meters. which means this is angle A and this is angle C. Now, first things first, when we're using these problems, we don't want degrees, minutes, seconds, so we want to switch that back into just degrees. What's that conversion to change this into just degrees?
55 plus 40 divided by 60.
Sweet. And we'll leave that as a fraction, 167 over 3, just so we don't have to round. Okay. So we know that we're going to use the law of sines. The reason I know I want to use the law of sines is because I have an entire ratio here. I have big B and little b, which means I'm going to use that ratio, that proportionality between the signs. So I'm going to set up my law of sines. I'm going to say the sine of big B over little b should be equal to the sine of big A over little a. Okay? We need to find big A. That's my missing thing right here. So I'm going to solve this equation using cross multiplication. So B sine of A equal to A sine of B. And then I'm going to divide by B on both sides. So this is A sine of B over B. And I'm going to figure out what this value is worth. So at this point, I want to plug some stuff in. To plug stuff in, I will plug in A, which is 25.1. I will plug in big B, which is 167 over 3. And I will plug in little b, which is 8.94. I actually don't have this number written down on my paper for some reason. Can somebody tell me what that's equal to? Okay, so we get that the sine of A would be equal to 2.318. Now, your spidey senses should be tingling, because can sine ever be equal to something that's 2 point whatever? No, sine is between 0 and 1, or between -1 and 1. So we automatically know that this is a problem. The sine that we solved using the law of sines, there's so many signs happening here, is too big. Sine of A will never be equal to 2.318. So that means that we have some sort of error, which means that our answer would be that there is no such triangle that fits this problem, that fits this description. There are 0 triangles we can use here. B was an acute angle, and the sine of the missing angle for my proportion was too big. Sine of A was equal to something bigger than 1, so we said it's an error. If you didn't notice this right here, and this is what I did in my notes because I was just going for it, I actually found the inverse of this to actually solve for A, and my calculator straight up told me error. So then I went, whoa, oh wait, there's not a triangle that will work for this. So if you get an error on your calculator, first check to make sure you didn't put a typo. But 2, there may not be a triangle that works, because that's what your calculator is trying to tell you. Either way, we use the law of sines in this ambiguous case, angle side side, and when we find out that there's an error, we stop. Sine cannot be bigger than 1. Okay, that's 0. There were no triangles that worked for that one. Let's look at example 2. Another ambiguous case, we have the triangle ABC, given A is 43.5, little a is 10.7, and little c is 7.2. Like I said, I always draw a triangle because it's super, ooh, that's an ugly triangle. Let me try that again. I find it super easy to visualize these problems if I have a triangle. Still not my best triangle, but it'll do. We'll call this A, which is 43.5 degrees. Little a would be across from it. And then little c is one of the other sides, so we'll call this C and we'll call this one little c, which means this is angle B. All right, so we start with the law of sines because we can't find like another missing angle, which is really what we started with last time using all angles add to 180. We don't have enough information. But we do have this entire proportion, big A and little a. So we use them in our law of sines. So here I go. Sine of big A over little a equal to the sine of C over little c. Why did I choose to use C's instead of B's here? because we have C. Yeah, I don't know any information about big B or little b, so we leave them alone. We can derive this question for sine of C. So again, we cross multiply. A times the sine of C equal to C times the sine of A. Divide by A on both sides. This would be C sine of A over little a. We can fill that number in. Sine of C, we can figure out what this is because C is 7.2. Sine of A is 43.5 degrees. And little a is 10.7. Somehow don't have that number written on my paper either. What was I doing? We get here that sine of C is equal to 0.4632 if we round that number. Is that what you guys got? So am I going to have a triangle here? Yeah, I will have a triangle. Now the potential is that I actually have two triangles. We don't know yet. We know that it will at least work once because this number that it's equal to is less than 1, between 0 and 1. Now, I actually need to solve for C, so I'm going to do the inverse sine of that number. I highly recommend in your calculator, don't use the rounded number. You have the number on your screen, so press second, sine, and then like go up and select that number. You know what I'm saying? So we get a really, really accurate number. Your homework will tell you how to round, but we'll round to 4 because that's what we're used to. We get that little c, or sorry, no, this is big C. Big C, let me put an angle symbol in front of it. Angle C is equal to 27.5933 degrees. Awesome. Hooray, we found C. The problem is, it might not be the only C value we have. There is a potential here that there are 2, because we don't know yet. So what we're going to do is we're actually going to sub-label these as angle C1, and use angle C1 to figure out what the C2 angle could be. So I come over to the side, and I check to see if there is a second case. Potentially, there could be another angle C, we'll call it angle C2, if we figure out what 180 degrees minus angle C1 is. That's a great question. Let me go back to a page. Okay. So we do 180 degrees minus the angle we just found, which was 27.5933 degrees. Beep, beep, bop, calculate that, and it's 152.4. We'll just round it to that for ease. So my question for you is, will this triangle actually exist? We know that the other option, the other value of sine that will return this 0.4632 is this value right here, 152.4. So we check. We take angle A plus angle C2, and we decide, we hope, that it is less than 180 degrees. So that we can have a third angle. We can't have two angles be equal to 180 degrees. That third angle doesn't have any degrees left for it. So when we check this, angle A is 43.5, and angle C2 we just found was 152.4. Is that actually less than 180? No, this is 195.9 degrees. That is not less than 180. So we won't have a second triangle here. We will only have one. If you found this actually worked, you will have to do everything we do to solve this triangle twice, because you have to do it with angle C1 and you'd have to do it with angle C2. But in this scenario, it doesn't work because this is too big. There's not even enough degrees left for your third angle. It's too big. So we solve. Well, let's write a note to ourselves so we remember. This means only one triangle. Okay. So we know there's only going to be one triangle. So I feel pretty confident placing this number for C1 in my image. This is 27.5933 degrees. There's a really easy answer to this. How do you find angle B now? Yeah, it's a triangle. They have to add up to 180. So once I know there's only one option, the thing I do to find angle B is I would do angle B is going to be equal to 180 degrees minus angle A and minus angle C. We know those values. We don't have to do it twice because we only have one option for our triangle. But we calculate all of this. We would get that angle B is equal to 108.9067 degrees. Hooray. So we can add that into our picture. 108 point, I already forgot the number, 9067. What's the only thing left to solve in this triangle? The side B, yeah, little b. So you can use the law of sines again in any of the ratios. I prefer sticking with the ratio that they gave you at the beginning of the problem, meaning I'm going to use the sine of A over A. They gave me both big A and little a, equal to sine of B over little b. And we are looking for little b, so I'm going to derive this formula for little b before I plug numbers in. We cross multiply. This part should be getting pretty fast for you. We're still looking for little b, so we'll divide by sine of A on both sides. That means little b is equal to A sine of big B divided by sine of A. Once it's all solved for your variable, it's very easy to throw things in there and actually evaluate. So we would plug into a calculator 10.7 times the sine of B, which is 108.9067 degrees, all divided by the sine of 43.5 degrees. Beep, beep, bop. That's a calculator question. We would get 14.7057 inches. Just because I can't help myself, I would add that back to my picture just because I like to see things finished. So boom, I have solved the entire triangle and there's only one option, but we checked for that second option just in case. Okay, now that was a whole lot. Took up a whole page of work. What are your questions? Where are they? Can I answer them for you?
Are we going to do one where there are two?
And so what would happen if I was doing this work for myself, and you'll see it in a second when we do one, after I saw that there was an entire other triangle I could do, I would put like a bar down my page so I knew I was solving both triangles separately. They use the same process necessarily, but different numbers. So main thing here, when you have side-side angle, this ambiguous case, when you first find that sine value or the C value or whatever your missing angle would be, because you used inverse sine, you have to take into account you might have missed one. So we always check to see if we actually missed one. Let's do this next example. Okay, we're going to solve triangle again. It's an ambiguous case. A is equal to 55.3, little a 22.8, little b 24.9. So my picture, first foremost, we have big A, which is 55.3 degrees. Little b is 24.9 feet. And little a is 22.8 feet. If this is mixed in with other problems, the way you remember this is the weird case is that you only know one angle. So I can't just quickly solve for the third angle so I have all the proportions. That's what we did last time. This time we need to start by finding an angle using the law of sines. So we'll set up sine of A over A equal to the sine of B over B. I picked B because I know the side length for B, so I can find the angle for B. We cross multiply and solve, so this is A sine of B times B times the sine of A, or equal to B times the sine of A. Solving for the sine of B, which is what we want, is B sine of A over A. Again, that cross multiplying and solving part could probably get really quick for you as we do them more often. I won't need to see all of the work once you get the patterns. But we're going to go ahead and see what this would be. This would be 24.9 times the sine of 55.3, all degrees, all divided by 22.8. And again, I don't have that exact number written down on my paper. Who am I? 24.9. When we do this, we get that the sine of b is equal to 0.8979. Are we okay? Or are we going to have triangles? Yes. If that number is bigger than 1, that's when you say no. But now we need to actually find out that angle. So if we solve for angle B, that means we are doing the inverse sine of that value. And again, don't use the rounded number, use the exact number. So you may just type it all in your calculator again. But when you do the inverse sine of all of that, you get that this first angle, potentially, that we're going to find here is 63.8792 degrees. Cool. We need to check to see if there is a second angle. What did I do to find that second angle? Subtract from 180. So I'm going to come up over here and I'm going to see. We might have a second angle if we take 180 minus angle B1, which means we're doing 180 degrees minus 63.8792 degrees. We calculate, it's a calculator question, 116.1208 degrees, which is potentially our B2. We just need to make sure it will work. We add the angle you were given plus this B2 angle and make sure it's less than 180. So we would say angle A plus angle B2 hopefully is less than 180 degrees, which is 55.5 plus 63.8792. Oh my gosh, I keep forgetting my degree sign. Hopefully that's less than 180. And when we do this, we get 171.4208. Is that less than 180? Yes, so we will have two triangles here. Your first triangle, you're going to say that the angle B is 62.8792. Your second triangle, you're going to say that angle B2, so your angle B, is 116.1208. So everything we do after this point, we're going to have to double. Me personally, when I do these problems, when there are two angles, I really do just straight up like break my page into two. Yes? Whenever, so again, you're checking for two triangles whenever you do the inverse sine to find an angle. So all last time you never actually had to do the inverse sine. You were always just solving for a side length given the angles because we could find the angles really easily. But when you're solving for a sine, or sorry, an angle and you do inverse sine, always check for a second triangle. Yes?
For B2, did you use angle B1 when you add angle 1? I mean angle A.
I sure did write that down, but I didn't do that actually in my head. Thank you. This should be B2, 116.1208. Thank you. Now that math makes sense. Okay, since there are two triangles here, I'm going to do one. You're going to finish the second. I'll go ahead and finish the red side. So it's all of this side down here. I'm going to make this line a lot longer for me, my big handwriting. So following the steps I did last time, when I know that I have angle B, I now have both angle A and angle B. I'm not going to add numbers to my triangle on this problem because there are two options that will get really messy. But I know that once I know all of the angles, I can find angle C1 by doing 180 minus angle A minus angle B1. So I do 180 degrees minus 55.3 minus 63.8792. Wow, I keep forgetting my degree symbols today. We get that angle C1, angle C for the first triangle, would be 60.8208 degrees. Check. Now I know all of the angles. What side am I missing? Little c. So we set up a law of sines proportion, finding little c. So I like to stick with what they gave me. So they gave me angle A. I'm going to use angle A in my proportion so I don't have to use a rounded number. But then I'm going to find big C over C. We're looking for little c, so I derive this formula for little c. A times the sine of C equal to C times the sine of A. We're solving for C, so we divide by sine of A. And then I guess I should be labeling these as ones this whole time, since this is the first triangle. So C1 would be equal to A, which is 22.8, times the sine of C1, which is 60.8208 degrees, all divided by the sine of A, and A is 55.3 degrees. Keeping track of which one's triangle 1 and triangle 2, utterly important. That's why I'm using those subscripts of ones. That means little c1, which we can just throw into a calculator and find, would be 24.2131 feet. That solves one of my triangles. Your job is to solve the other. Again, I wrote, feels weird to write on the right side of your paper before the left, but just because I solved them with the B's that way, that's why I've done this. So this is all one triangle. This will all be one triangle. That's why I'm setting my paper up like that. I want you to basically redo these steps, the green and the blue steps, but you're going to be using the purple B2 angle instead of the red B1 angle. So if you can solve the other triangle for me in the next couple minutes. I'll leave this where we can see everything. Okay, hopefully I'm not completely cutting off your thinking. If we were solving this one with the purple angle for B instead of the red angle for B, we'd pretty much follow the same steps here. So we'd find angle C2 same way by doing 180 degrees minus angle A minus angle B2 this time, which is 180 degrees minus 55.3 degrees minus 116.1208 degrees, which means that angle C2 would be equal to 8.5792 degrees. Did we get that one? Fabulous. Now we can use that information to do the blue steps, which is using the law of sines. I like to use the proportion that they gave me, which is A over A, to find sine of C2 over C2, angle C2 over C2. We cross multiply and solve because we're solving for C2 here. So it's A times the sine of big C2 equal to little c2 sine of A. Solving for C2, we would divide both sides by sine of A. So that's A times the sine of C2 over the sine of A. And that's the stuff we can plug in, which is going to be 22.8 times the sine of C2, 8.5792 degrees, all divided by the sine of A, 55.3 degrees. Beep boop bop, calculating it up, we should get that C2 is 4.1370 feet. How did we do? Nice. So again, the main idea here is using the law of sines is great until you do an inverse sine, because when you do an inverse sine, you may have forgotten about the other angle in quadrant 2 that gives you the same values. We just have to check that purple stuff to make sure that we can find the second angle and that second angle actually makes a triangle. If this number, when you add them together, is too big, we leave not enough degrees for the third angle for us to even use at all. So it has to be completely less than 180 so that there's a third angle. Was that the door? That was super polite. That's all we have for this one. The section of homework of this one will look exactly like section 7.1. It's just that you may also have to answer how many triangles have come up. So you do like we did in that first example with the triangle. I believe it was example 1, where you do the sign, and if it's 0, 1 or 2 triangles is what it's going to ask. Okay, you have the rest of the class period, which is a good amount of time to work on this. If you saw on the board, I'm not going to make any of the chapter 7 homework due until the night before the test. Mostly because we have so many breaks in what we're doing for all of these STAR testings and who knows what else for the next few weeks that I can't keep up with what dates we have school and don't have school. So all of the Chapter 7 homework is due the night before the Chapter 7 test. Don't wait until then because there's a lot of problems. But that way you can, takes you a while. But look, you got all these STAR days where you're doing nothing. You can do some math. Oh, I left this on.